Auzu billahi minash shaitanir rajeem. Bismillahir Rahmanir Rahim. This video will teach you how to convert a decimal number with a fraction part into a binary. Evidently, the resultant binary number will also be a fraction, and it will give, in the given example, we are provided with a decimal number, specifically 45.25, and our objective is to determine its corresponding binary representation. The decimal number is partitioned into two segments. The first part is an integer, specifically the number 45, which is located left of the decimal point. The second part is fraction, which is located to the right of the decimal point. And firstly, we convert the integer part 45 into binary. And for this purpose, we perform the division operation of 45 divided by 2. The outcome is 22, accompanied by remainder of 1. Again, perform the division operation of 22 divided by 2. The outcome is 11, and the remainder is 0. Perform division operation of 11 divided by 2. The resultant is 5, with remainder of 1. We perform the division operation of the 5 divided by 2. The resultant is 2, with the remainder is 1. We perform division operation of the 2 divided by 2. The resultant is 1, remainder is 0. And then lastly, we perform 1 divided by 2, remainder is 0. Sorry, output is 0 and remainder is 1. When output is 0 or remainder is 1, this means that division has been completed. And now we start from bottom to the top. And bottom is 1, 0, 1, 1, 0, 1. So 45 is equivalent to 1, 0, 1, 1, 0. Now we will perform conversion of a decimal fraction, which is 0.25 in binary decimal, binary fraction. For it is opposite to the integer part. In integer part we divide, in fraction part we multiply. So here, by calculating the product of the 25 by 2, the outcome is 5, and remainder is 0. Now outcome 0.5 is multiplied by 2. The outcome is now 1, with a whole number component of 1, and which shows that it is exactly represented by the fraction. So now we write the fraction conversion. It is opposite to the integer. Integer we start from the bottom and go to the top, but for the fraction we go from the top to the bottom. And top is 0. We always take the integer part 0, and bottom is 1. So 0.25 is equal to the 0.01. Now we combine both parts, integer part and fraction part. So our conversion of the 45.25 in binary can be written as 101101.01. It is the required conversion of the 45.25 into binary number. In another example, we want to convert 5.0725 into binary. The decimal number is partitioned into two segments. The first part is integer, specifically the number 05, which is located to the left of the decimal point. The second part is a fraction located to the right of the decimal point. Firstly, we convert the integer 05 into binary. As we did in our previous example, that integer conversion into binary is successive division operation. So therefore, we perform the division operation of 5 divided by 2. The resultant is 2, and with the remainder of 1. We again perform the division operation of 2 divided by 2. The resultant is 1, with the remainder is 0. When resultant is 1, it means that our binary conversion has already achieved. So we start from the bottom to the up for the integer. So our 5 can equivalently in binary is just like 101. Now we perform the fraction part conversion, and for that purpose we use opposite operation. In decimal we divide, but in fraction we multiply. So we will convert 0.0725 into binary. We multiply it by 0.0725 by 2 is equal to 0.145, which is less than 1. So that's why our integer part here is 0. So we write this integer part as here 0. Now the resultant 0.145 we multiplied by 2. Our answer is 0.290. Here our integer part is 0. So we write this 0 is here, and the remaining is 0.290. We multiplied by 0.290 by 2. Our answer is 0.580, where again our integer part is 0. So this 0 again right here. Up now 0.580 multiplied by 2. Then our answer is 1.160. At that time, in this time, our integer is 1. So we write our integer is here, that this one. And our fraction point part is 0.160. So we multiplied by 0.160 by 2 is equal to 0.320, and our integer part is 0. And similarly, 0.320 is multiplied by 2. Our answer is 0.640, and our integer is 0. And 0.640 multiplied by 2, our answer is 1.280, and integer part is 1. Now we have performed 7 bits significant. Obviously, it will continue after 10, 15, 13, 14, any number, we will get the exact uh, conversion of 0.0725. 7 or 8 bits are significant to represent in our exam. So we just write that 5.0725 approximately equal to the 101.0001001, and which is the required conversion of 5.0725 decimal number into binary. Thank you.